All right, we are back in the lab today. I'm going to do a calorimetry lab. So first thing is safety. So got my goggles, got my gloves. The most dangerous thing that we're going to be working with today is hot water. So as long as I don't spill it on myself, I shouldn't need an apron. So safety first. All right, we got our safety. We are ready to go. The purpose of this lab is to try and calculate the specific heat of aluminum. So what we're going to do is we're going to use a calorimeter, which will allow us to calculate or measure and then calculate heat lost from the aluminum and the heat gain from the water. So these are our materials. We have our styrofoam cup calorimeter and my makeshift lid. Now, if this were ideal, we would have a lid on here so that none of the energy would escape from the cups into the environment. But I don't have a lid, so I made one. It's not going to be perfect, but it'll work good enough. So I also have a thermometer to measure temperature changes. I have my aluminum here, and then of course I've got a beaker full of water. From our heat equation, we have to know how much we have. We have to know the mass of our object. Okay, so I want to get about 10 grams of aluminum. I need to measure my mass, so I'm going to take my aluminum, make sure I tear this, and I'm going to try to get as close to 10 grams as I can. Let's see how well I do. Oh, a little much. Close enough. Okay, so the mass of our aluminum is 10.007 grams. Make sure you record that in your data table. And then we need to heat this up, and I'm going to do that by putting it in a hot water bath. My hot water bath is starting to heat up. The reason I use a hot water bath is because I need to heat up my aluminum, but I need to know how hot it is. I need to know the temperature. So if I heat up my water and then I take the aluminum and put it in my hot water bath and I let it sit for a few minutes, then whatever temperature my hot water is, that's going to be the same temperature as my aluminum. Okay, so I'm going to take my aluminum and put it into the hot water. But I don't want the aluminum to get wet because that's going to change the mass, right? I don't want to take my aluminum here and just throw it into my hot water. So here's what I'm going to do instead. And then I'm going to put the test tube into my hot water bath. That way, the test tube will still heat up, the aluminum will still heat up, but it won't get wet. It won't change the mass. So now all I have to do is wait for this water to get hot enough, and then that will heat up my aluminum, and then I can put it into the cold water and measure the heat exchange. Is heating up and my aluminum is heating up. Let me show you and talk to you about this calorimeter. So this calorimeter here, this is when it's fully put together. It's just 2 styrofoam cups, and then I've taken part of a styrofoam cup and kind of turned that into the lid, put a hole in it, and that's where I'll put my thermometer. Hopefully this will trap in as much heat as we can. As much of that energy will stay in the system and not get into the environment. One thing to remember when you're setting up a calorimeter is you want the thermometer to be in the water, but you don't want it to touch the edge. You don't want it to touch the bottom. So I've got to put in enough water so that the thermometer will be in the water, but not touching any of the sides. 100 milliliters of water. Since we're not doing any reactions in the water, just regular tap water is fine. It doesn't have to be exactly 100 milliliters, but that's kind of what I'm shooting for. About 98 milliliters, and that's totally fine. I just need to know the mass of my water. So I'm going to put that on the scale, and it's about 96, so it's exactly 96.47 grams is the mass of my water. 96.47 grams is the mass of my water. And I'm going to put it into my calorimeter, trying very hard not to spill. And like I said, I need to make sure that my thermometer can get into the water but not touch the sides. And I'm not quite there. I don't know if you can see that I'm not quite there yet. There we go. So that'll be perfect. So that'll work. Again, this isn't going to trap all of the energy. This isn't a perfect calorimeter, but this is going to work. My aluminum is heating up in the hot water. I'm going to take the initial temperature of the water in my calorimeter, which it looks like is, I don't know if you guys can see that, it's 21 degrees. 21 degrees Celsius is going to be the starting temperature, the initial temperature of our water. Okay, just a couple minutes left until the aluminum is hot enough, but I wanted to take just a minute and talk about what it is that we're doing so that make sure that we all understand. It's aluminum, and I'm going to put it into this 20-degree water here. What's going to happen is the heat from the aluminum is going to go to the water, and I'm going to measure the change in temperature, right? I'm going to measure the temperature of the water every 30 seconds. And we're going to see how much that temperature changes, how much of that heat goes from the aluminum to the water. Okay, the hot water has been heating the aluminum for about 7 minutes. So I'm going to come over here and check my temperature. The temperature is, I don't know if you guys can even see that. It's barely over 100 degrees, so I'm going to say 100.5. So it's 100.5 degrees for my aluminum. Now what I'm going to try to do is I'm going to try to take the aluminum and put it into my calorimeter as quickly but as safely as I can so that I don't lose any of the heat, or I lose as little heat as possible. And then I'm going to start my timer, and I'm going to record the temperature every 30 seconds. All right, here we go. Let's see if I can do this. All right, let's see if I can do this as quickly as possible. I've started my timer. Already you can see that the temperature is starting to go up a little. At 30 seconds, so in just a few seconds, we'll go ahead and record that temperature. So let's see what we get here. Right at 30 seconds, we're at 23 degrees. So it's 23 degrees Celsius at 30 seconds. There is 23 degrees Celsius, 23 degrees Celsius. We are still at 23 degrees Celsius. All right, coming up on 2 minutes, 120 seconds. Right at 23, still at 23. Okay, at 2.5 minutes, we are just below the 23, so I'm gonna say 22.9 degrees. Last time interval at 3 minutes, 180 seconds. Yep, still at that 22.9 degrees Celsius. That's it for trial 1. We've got all the data that we need. Now we'll move on to trial 2. For trial 2, just like for trial 1, I want to get about 10 grams of aluminum. So I'm going to put my weigh boat on there and tare. And then I'm going to get about 10 grams of aluminum. Again, it doesn't really have to be close to 10. It's just a nice even number to shoot for. What's important is that I record how much that I have. So about 10 grams. Take a little bit off there. There we go. So 10.006. Oh, sorry, 10.06. 10.06 grams is going to be the mass of the aluminum for trial number 2. Trial 1, I'm going to take my aluminum and I'm going to heat it into my hot water. I'm going to put it into my test tube first, nice clean test tube. I'm going to put the aluminum into the test tube, and then I'm going to put that into the hot water for a few minutes so that I can measure the temperature of it. 100 milliliters, probably about 102, 103. So looking at our mass for this trial, the mass of our water is 101.27 grams. So the mass of our water is 101.27 0.27 grams. Trial 2. So this water is about 99.5 degrees. 99.5 degrees is the temperature of our metal, 99.5 degrees. And now I'm going to look at the initial temperature of my water in my calorimeter. It is at 21.5 degrees for the temperature of the water. 21.5, 99.5. And now again, I'm going to take the metal from here, put it in my calorimeter as fast as I can, put the lid back on, and then we'll start measuring the temperature every 30 seconds. All right, here we go. Trial 2. See if I can do this one any better. Coming up on my first 30 seconds, and I'm at 23 degrees. 23 degrees. All right, coming up on a minute on 60 seconds, and then we'll check the temperature again. And here we go. I am now up to 23 degrees. Again, 23 degrees Celsius. Let's do 23.1. Let's call it 23.1 degrees Celsius for the temperature at 60 seconds. Coming up on 90 seconds, the temperature is 23 degrees. Nope, 23.1. 23.1 degrees Celsius. On our 2-minute mark, 180 seconds, we're at 23.1. Still at 23.1. All right, the 2.5-minute mark, here we go. We're up to 23, I'd say 23.2. We've come up a little bit, 23.2. Maybe, let's see. 23.2 degrees. Last one at 3 minutes, 180 seconds. We are at 23.2 degrees Celsius. All right, so that's our lab for today. I'm gonna go ahead and take my goggles off. Oh man. So that's our lab for today. Don't forget to do your post-lab analysis, as well as filling out your data table and the pre-lab questions. I think there's only one pre-lab question this time, so that should be pretty quick. I did want to mention, it's very, very important, and I don't know if we would, if I mentioned this before, because this is a sealed system, right? Because the calorimeter is a sealed system, none of the energy is leaving it. None of the energy that we put into the metal when we heated the metal is leaving the calorimeter. All of that energy, all of the energy from the aluminum is going to the water in the calorimeter. So however much energy the aluminum lost, it's the same amount that the water gained. So you're going to do the Q equals MC delta T for the aluminum. Since we have a starting temperature for the aluminum, it was the hot temperature, and the ending temperature is going to be the same for both the aluminum and the water. You can calculate how much energy the aluminum lost. That is the exact same amount of energy that the water gained. So as you're doing your calculations, keep that in mind. All right, so if you guys have any questions or need anything at all, feel free to reach out, let me know. I'm here. Send me an email, send me a text, something. But yeah, if you have any questions, let me know. Thanks, guys. See you later.